So we're going to be doing review here, and what I'm going to do is I'm going to pick one problem from each column. These are similar, these are similar, these are similar, these are similar. So I'll just randomly pick one, and then you'll do the other two for homework, okay? So I will pick this one. When I do this problem, let me zoom in a little bit. I have a choice. I could either do it as 2 to the 4th, 2 to the 6th, or I could do it as 4 squared. Oh, hold on, I gotta put my glasses on. Okay. And that would be 4 cubed. Now that my bases are the same, set them equal to each other. Okay, and I'm going to show you how to check it real quick, so let me get it on Desmos. So what I did is I inputted the original problem. I had to make sure I put the x plus 7 in parentheses. For some reason it didn't want to put both of those as a little number or exponent. So when I did that, if you look, let's see if it will let me. Well, it won't let me, but you can see 1, 2, 3. X equals 3, that's what I got. So now I know that I'm good to go. Okay, and if some of you go, I don't believe it, you could go to a table. Oh no, it's not letting you do a table because it's not an equation. So if I would have changed that to, would have changed this to y equals, and I would have made this side an equation, so 16 to the 5x, and then made another equation, y equals 64 to the parentheses x plus 7, then I'd be able to do a table. Okay, I think I did something wrong. I must have plugged it in wrong. Okay. All right, but you guys get the game. So with that being said, that means these two will be homework. Okay. I will do this one because it has a decimal, so I think it would freak you guys out. Actually, you know what? This one is more similar to this one, so I'm actually going to pick this one. So the problem with this one is that I cannot make the bases the same. If I can't make the bases the same, I need to change it to base 10. The only way to change things to base 10 is to log both sides. Once I log it, now if you look at the right side, that's log base 10, 15. Because remember what we want? We want the bases to be the same. Now remember what happens to the little? It gets big. And then log 12. So that parenthesis, that little became big. Now what's the goal? The goal is to get x by itself. So I got to get rid of this, 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 and this. This is furthest away, so I'm going to divide by log 12. And then I'm left with 2x minus 8 equals whatever log 15 over log 12 is. Okay, I don't know what that is right now. And then I would, you know what, I can do that right now. Sorry. Actually, I'll pause it. It'll take a second. So I'm going to want you to round to the nearest hundredths. So it's $1.08, but the 9 means $1.09. So that's really 1.09. And now how do I solve? I add 8 to both sides. If I add $8 to a dollar, I'm now at $9.09. Divide by 2, and I get x equals, and I just go like this, and I go 9.09 divided by 2, and I get 4.545. I'm not going to accept that. I want it like dollars and cents. So I want it as 455. Okay? Now, I'm going to show you how to check it in a different way. So what I can do is I can take this answer and put it in for x. When I put it in for x, it should equal 15. So let me pause that and show you. So I put 455, 2 times 455 minus 8. Now, if you look, it says 15.35. What is it supposed to equal? 15. Well, why is it not equaling 15? Because remember, way back here, we rounded, and we rounded up. So that means since we rounded up, my eventual answer will be bigger than my real answer. Now, it means you did it right, but if this was 16, then you're pretty off. If you have some extra cents, but your dollar matches up, you're pretty good to go. All right? Okay, that means you'll do these two, okay? Now, by the way, could you do the log thing for this one? Yes, you could. But if you do that on your quiz, I will not accept it because the most efficient way is to not use your calculator. As soon as I have to use my calculator, then things get messed up, they take longer, and I'm relying less on your brain and more on the computer brain. I don't like that. Okay, so I'm going to do this one, and I'm going to go, can I make the bases the same? I can. I know 64 is 2 to the 6th. I know 32 is 1 over 2 to the 5th. But since this is a fraction and this isn't, I want to make it not be a fraction, so I make it negative, and then times 2x. Now my bases are the same. Multiply. Simplify. If you give me 6/10, I will mark it wrong. And some of you go, well, then how do I do that? How do I know to simplify? Go 6 divided by 10 in your calculator, and see how it says 0.6? If you press the fraction button, it simplifies it for you. There are no excuses. Okay? All right, let's do this last one over here. Okay, well, how is this different? Well, this is different than all the above because all of these, let me zoom out a little bit, sorry. All of these were in exponential form. So since all of these were in exponential form, I make the bases the same and I'm good to go. Now, why did I do a log? Because I couldn't make the bases the same. So now that I'm in log form, what the heck do you think I want you to do? I want you to change it to exponential form. Okay? So, in order to do that, though, I've got to look at this. And I'm actually think I'm going to just do the first one. Yeah, I can do the first one. It'll be fine. So when I do this one, the first thing I'm going to do, anytime I see a little, in log form, not in exponential form. This is exponential form. I can't make that x big. But I can make this big because it's in log form. So I'm going to make that big. And now I want to change it to exponential form. But I can't change it to exponential form with that 5 in the way. So the 5 is being multiplied, so I divide by 5. Now that it starts off saying log, boom, I can change it to exponential form. 64 times 4, 128, 256. Now, can I check my answer? Yes, I can. But the thing that you need to know about Desmos is if you just plug in log base 4, 256 to the 5th, it thinks you're taking all of this to the 5th power. So what you're going to have to do is put parentheses around this so that it knows you're just taking the 256 to the 5th. Okay? All right, let's finish on the next page. I'll pick one. Let's see, which one should I do? I'll do this one over here. Okay? Well, this one, I want the logs to go away and I have 2 of them. Well, technically, they're both in what? Base 10. So if they're both in base 10, just like if I had this, base 10 and then blah, what would you do? You would set blah equal to blah. So guess what? I take this and I set it equal to that. Because the bases are the same, now x equals 16. Okay? And if you look, 16 plus 9 is 25. 2 times 16 is 32. Minus 7 is 25. Now I know that I know. And I'm good to go. Okay? All right, let's do a different one. Let's do this one over here. Okay? So, if I made this little big, then these logs would not be the same. Okay? So they have to be the same. So they both have to go log something to put them together. So, what do I do when I'm adding? It means I multiply. So it's really log of 25x squared equals 2. Now it starts off being log. What do I do as soon as it's just one log? Boom, change it to exponential form. But what do I need to make sure I do? I have to remember that's in base 10. So now I change it to exponential. I know 10 squared is 100. Divide by 25. Square root, x equals plus or minus. Oh, I almost messed up. X equals plus or minus 2. Okay? Now, if you remember from other stuff, if you get a negative answer, are you right? Well, can you take the log of a negative number? You cannot. But if you have negative 2 and you square it, it's now 4 and it's a positive number. Okay? So your homework is to finish all of those.